All right, let's jump straight into this explainer. If you're building Retrieval-Augmented Generation, or RAG systems, you already know the retrieval mechanism is literally the beating heart of the whole operation. Today, we're taking things up a notch. We're going to look at a pretty brilliant architectural strategy to take your system from a basic prototype to a rock-solid production-ready solution by combining semantic and lexical search.
Here's the roadmap for today. We'll start with the RAG retrieval blind spot, then compare semantic and lexical search. After that, we'll set up our engines, figure out how to fuse ranks with RRF, and finally, run a real hybrid search test.
Section 1. The RAG Retrieval Blind Spot.
To kick things off, we've got to talk about the hero of our story, semantic search. When you build your first prototype, honestly, it feels a little like magic, doesn't it? It's fueled by dense vectors, mapping the underlying meaning of words into this massive, multidimensional mathematical space. But here's the catch. When you push that system into a production environment, your users start throwing highly specific queries at it, and boom, a hidden vulnerability is suddenly exposed.
And that brings us to the semantic blind spot. Look, dense embeddings are absolutely incredible at picking up the vibe or the broader context of a query. They handle synonyms like a champ. But they have a massive blind spot when a user needs an exact, precise keyword match. If someone is hunting for a specific serial number, an obscure acronym, or a strict proper noun, semantic search might just gloss right over it. Why? Because it's too busy looking for the conceptual meaning instead of the rigid, exact letters on the page. And that is exactly where we need to call in some backup.
Moving on to Section 2, semantic versus lexical search.
To fix this blind spot, we're actually bringing in an unlikely, older ally, keyword search, but, with a modern twist. The contrast here is just perfect. On one side, semantic search handles all the nuance and context. On the other side, we have lexical search, specifically the BM25 algorithm, where the BM stands for best matching. BM25 completely ignores the vibe. It scores documents based purely on how frequently those exact search terms show up. Combining these two, that's the secret sauce for a truly production-ready system.
Section 3. Setting up the engines. So how do we actually build these two engines in Python? You're going to need 3 specific external libraries. First up, rank_BM25. That's our BM25 algorithm implementation. Second, sentence transformers, which gives us the pre-trained language models we need to generate our text embeddings. Now, in the real world, you probably already have a vector database set up, but we're just using this to simulate a toy version from scratch. And finally, requests. We'll use this to pull down a tiny 9-document dataset of Asian countries from a public repository. That way, we actually have some real knowledge-based text to search through.
Our overarching hybrid architecture works in 3 very distinct steps, and the really brilliant thing here is that the first 2 happen in parallel, totally independent of each other, which is incredibly efficient. First, we tokenize our documents into sublists of words and rank them using BM25. Second, we use a sentence transformer to grab our embedding vectors, and then we rank them semantically using cosine similarity. And finally, step 3 is where the magic happens. We fuse them together.
Section 4. Fusing ranks with RRF.
But how do you actually glue 2 completely independent, fundamentally different engines together? Enter Reciprocal Rank Fusion, or RRF for short. This is the absolute gold standard in the industry for merging this kind of ranking data. RRF calculates an overall ranking by rewarding the documents that pop up near the top of both your BM25 and semantic lists. It essentially works like a harmonic mean. It heavily penalizes a document if it tanks on either list, ensuring that only the most consistently relevant documents make it to the very top.
Now, you might be wondering, and honestly, this is a trap a lot of developers fall right into, why don't we just add the scores together? Well, you absolutely cannot just add the raw calculated scores. It's a recipe for disaster, because BM25 and semantic search operate on entirely different numeric scales. Semantic vector similarities might output a nice tidy little fraction, while BM25 might spit out much larger raw numbers. If you just slapped them together, one engine would completely drown out the other. You have to balance the scales by looking at their actual rank positions instead.
Finally, Section 5. The hybrid search test.
All right, it's time to put this whole better together theory to the ultimate test. We've got our data set of Asian documents, we have both of our engines revved up, and we have our RRF fusion method ready to go. We're going to feed this exact query into our Python script. Which nation is best known for rice fields and patties? Now, before we reveal the results, just think about it for a second. How are our 2 engines going to interpret this? Which one is going to pick up on the conceptual nuance of a nation, and which one is going to latch onto the exact keywords like rice and patty?
When we break down the results, the synergy is just so obvious. In the semantic results, the engine understood the abstract concept of a nation and gave us Vietnam, South Korea, and Thailand. Meanwhile, the BM25 engine went hunting for the exact keywords rice, field, and paddy, returning Indonesia, Japan, and the Philippines. Then we hit the hybrid RRF results, and it balances them out beautifully. By rewarding the documents that performed well across the board, it gives us the ultimate top 3, Vietnam, Thailand, and Indonesia. Even on this tiny dataset, it's clear the blind spots of one engine are perfectly covered by the other.
Scaling your RAG solutions to a production environment means you absolutely cannot rely solely on semantic search. You need that lexical backup. It's crucial. But I want to leave you with a bit of a challenge to test your understanding. As you build your own production systems using this hybrid architecture, try tweaking the query. Run some searches about Eastern destinations involving temples, beaches, or mountains, and ask yourself, when did these two engines completely agree? What specific kind of query phrasing causes that semantic vibe and those lexical keywords to align perfectly? It's a pretty fascinating puzzle to solve as you optimize your own systems.